Hello, hello. Welcome back. Spring break learning time. Just hope that you are all staying safe and staying at home, hanging out. Hopefully, you can learn a thing or two today. And let's talk about tornadoes, shall we? Again, if you've taken the Earth Systems class before and you know all about tornadoes, maybe this will be a good refresher. Woo. All right. So let's get into it on tornadoes. And if you haven't taken the Earth Systems class before, then awesome. Hopefully, again, you learned some stuff about these really cool natural phenomena we call tornadoes. So it's a rapidly rotating column of air that's in contact with both the surface of the Earth and a cumulonimbus cloud. So really, it's just a spinny death wind, right? It's very, very scary. These things can get super powerful, and we'll talk about that. Obviously here, this is a true tornado. We can see that it is a rotating column of air, and there's the cloud above it here, and then down to the surface, making contact there. So this is a true tornado. Oops. So tornadoes are a very extreme type of wind, right? A very extreme of wind. Maybe I should edit this. You're seeing this in real time, everybody. Oh yeah. Type of wind. I could go back and restart this and you would never know that I made that mistake, but I don't really care. So there's that. So we use what's called the Fujita Scale to measure the power and destructive capability of a tornado. We can see here that down at the bottom, the EF0, it's between 65 and 85 miles per hour. I don't know why we're using miles per hour. This is a science channel. Anyway. So in terms of kilometers an hour, it's about 110 kilometers an hour to about 140 kilometers an hour. And it's not that fast. It's not unreasonably fast, but it's still pretty dangerous. Generally, they don't do a whole bunch of damage. EF1, between 86 and 110 miles an hour, or about 140 to 160 kilometers an hour. They do a little bit of damage. EF2 is where it starts to get really dangerous. So in EF2, we'll pull the roof off of a structure, just pull it right off. So that's really scary. Most of the time, we're worried about the roof staying above us, right? That we want to hold the roof up. But hello, virus threat and protection. Thanks. However, in an area where there's a lot of tornadoes, you might want to think about actually holding the roof down and not just holding it up. EF3, so EF meaning enhanced Fujita. EF3, here we have the walls can collapse at this power between 130 and 165 miles per hour, which we're talking around 200 kilometers an hour, which is pretty serious. EF4 will just blow down an entire house, right? So all the walls come down, right? It's the big bad wolf scenario. I'll huff and I'll puff and I'll blow your house down. This is the amount of power that an EF4 has. It's hugely powerful. Now we're at 166 to 200 miles per hour, which is 250, 260 kilometers an hour. Very, very scary, very powerful. And then EF5, which there are not very many of these, but an EF5 tornado at 200 plus miles per hour sustained winds will just blow an entire house away. So in comparison, a hurricane, which you may know a little bit about, hurricanes don't generally have as high wind speeds. Hurricanes can be very, very dangerous, but they're mostly involved with water, right? It rains a whole bunch, and hurricanes are gigantic and last for days. Tornadoes last for a few hours at the very longest, and they don't they're not huge. They're very small, so just a few meters across. And so they kind of short-lived. They have higher wind speeds, and they don't form over water necessarily. Hurricanes have to form over the ocean. All right, so wind speeds can reach over 200 miles per hour or about 340 kilometers an hour. That is terrifying. So the United States has more tornadoes than any other country in the world. Interestingly enough, there are more tornadoes here in the United States of America than any other country. And in some years, there are more tornadoes in the U.S. than every other country in the world combined. Pretty crazy. So generally, when we talk about these kind of phenomena, they happen mostly evenly spread or just kind of randomly around the planet. Here is where almost all of the tornadoes occur here on Earth, is in the United States. And it is a special area, dangerous area called Tornado Alley. So it runs from Texas, Oklahoma, Kansas, Nebraska, the very eastern side of Colorado and Wyoming. For some reason, New Mexico seems to be completely safe of this. It's kind of weird how it's like right on the border of New Mexico. And then up into Iowa and Minnesota, the Dakotas. So really this whole area, and obviously there are other tornadoes that happen outside. I mean, we've had tornadoes here in Utah before. There are tornadoes that happen everywhere else, but Tornado Alley has the majority of the tornadoes in any one year across the entire planet. And that is because of the combination of several different things. Cold, dry air coming from the Rocky Mountains, combining with warm, moist air coming from the Gulf of Mexico, and then mixing together. They run into each other. And we'll talk about how that happens. And then this warm, dry air coming from southern New Mexico, Arizona, and of course northern Mexico. So these forces running into each other create these really powerful storms that we'll just talk about in a second. And then the jet stream here, which is a high altitude wind, kind of serves to mix them all together. So this is a very interesting combination of different forces. And you can see here that we have this wet, warm front here and a dry, cold front that run into each other, the cold air and the warm air striking each other in this central area of the United States that we call Tornado Alley. So tornadoes form from specific storms called supercells, and this is a supercell. This is an incredible image here. You can see this gigantic cloud, and it has this spinning. These supercells they move quickly, they form quickly, they look really cool. They're dangerous, and even if a tornado doesn't form, they can cause very, very heavy thunderstorms, including very large hail, a lot of lightning, and the process of tornado formation happens inside of these. It's not super well known. We understand it a little bit, but what we do know, or at least what I know, what I've seen, I will discuss here. So here we have our supercell, and this thing is kilometers wide, just an absolutely gigantic cloud. Very, very cool. Here's another supercell in greater detail here. You can see this very large, flat portion on top, and then it comes down into the actual portion that sends down the rain and so forth. Very cool. Beautiful to look at, but can be quite dangerous. So a supercell is a thunderstorm characterized by the presence of a mesocyclone. Mesocyclone, it's an important thing to understand. A mesocyclone meaning middle spinning. So meso means middle in Latin. Cyclone means something that spins or is circular. All right. So a middle spinning, a deep, persistently rotating updraft. So this air coming from the surface, it's warm and it goes up into the air and it is spinning as it goes up. For this reason, the storms are sometimes referred to as rotating thunderstorms. And you can see here that this supercell is rotating this direction. So it's going from left to right here, spinning around. All right. Here in the center, you can see that it's kind of green in color. This is the color that the sky turns before a tornado. And if you ever see the sky being that color, I would highly recommend getting inside. Because first of all, it's going to rain, maybe hail. It's going to be very, very, a lot of thunder, a lot of lightning. It could be pretty dangerous. And it's possible that a tornado might form. I've seen this a couple of times in my life. Here in Utah a couple of times, as well as once in Montana. And these thunderstorms, they hit and you look up and you see that green sky and there's hail and rain and lightning. It's pretty crazy. So this is a supercell storm. Mesocyclone, that's something important. Middle spinning, all right? So here we have not an animation, but an illustration of, here's the mesocyclone, this updraft here in the middle, in the pink. As it goes up, it spins, right? And then down the sides, you have these downdrafts. So you have an updraft going up in the middle and it's spinning. And then the sides, you have a downdraft flanking that. And this is what leads to the tornado forming at the base, is that updraft is going up and then these downdrafts are actually pulling the updraft out of the cloud down toward the surface. This creates an overshoot at the top. I'm not going to go through all of these terms here. The rear flank downdraft, the forward flank downdraft. Really what I want you to understand from this graphic here is that there's a cyclone going in the middle, and then you have these downdrafts along the sides going down, pulling down on the updraft in the middle. So a tornado forms when warm air going up hits cold air going down. So remember that air that is pushing down is pulling down that updraft, that mesocyclone. This creates what's called a funnel cloud. And you can see the formation of a funnel cloud here. This is not a true tornado because it hasn't contacted the surface. So the mesocyclone is being dragged down toward the ground by the downdraft on either side of it and creates a funnel cloud. I've seen these a few times. Pretty scary. All right. So funnel cloud is a cloud obviously being pulled down. It's a mesocyclone that's being pulled down by the draft, but has not quite contacted the surface. Again, we have another image here. You can pause this if you'd like and check it out. I'm not going to go through the whole thing. So again, once this bottom portion of the mesocyclone contacts the ground, that becomes a true tornado. And these things can be very, very dangerous. I would recommend checking out a few YouTube videos of tornadoes. It's pretty frightening. I know this was a short video, but hopefully you learned a thing or two about tornadoes. They are very, very cool. They're beautiful, but destructive. You ever see this? Seriously, get inside, maybe go to the basement. These can be very, very scary and destructive. Thanks for learning with me over your spring break. And I hope that you're all staying home, staying safe. You're all awesome. Have a fantastic day. We'll talk later.